Hi, welcome to our talk today. So we're going to talk about DBT and DevOps. Hopefully it's a conversation some will see as a bane in your life, others will see as super exciting. I'm your presenter for the day. The reason I say this, I'm with very talented people who are going to talk about the meat of the matter. I'm the lead data architect at Datatonic, and I'll let my colleagues introduce themselves very quickly.
Cool. Hi, I'm Alex Paisel. I am the principal DevOps at Datatonic.
And I'm Stan Hill. I'm a senior cloud architect at Datatonic.
Thanks, guys. Just a very quick overview of who we are. We're Datatonic, a leading data analytics and AI/ML specialist. We're a 5-time Google Cloud Partner of the Year award winner. We also partner with, amongst many names, DBT themselves, DBT Labs. Couple of logos in there for you in terms of some global clients who've trusted us to build data analytics AI/ML platform. As specialists, we also have in-house instructor-led academy where we assist the process of enablement through certified trainers. Right. Very quick overview of the agenda. So we're going to do a quick walkthrough about the topic itself. Then we're going to dive straight into the meat of the matter, talking about today's topic, DevOps, but also talking about modern data stack, reliability, all that kind of stuff. And then get to DBT and why we think DBT is a game changer, big tagline there, obviously. And then we'll walk through some couple of demos, which my colleague Alex will walk you through, to show some of these words into practice. And then we have a bit of a curveball here. Obviously, I'm sure if you've been to any forum this year, Gen AI is just all over the place. So my colleague Stan has prepared a little teaser here around how we see DevOps, DBT, and Gen AI all sticking together. And then Q&A, but don't worry, we'll try and do this very quickly. We don't want to stand in the way of you and the bar. So, right, so quick overview of the conversation. It's a bit of a wordy slide, but the idea is that behind any good modern data stack is a solid DevOps design. Why do we say this? Is if you're building a modern data stack at scale, everything around data reliability, quality, it's really, really important. But you also need to rely on process automation. So all of the good stuff that we like about DevOps and modern data stack. However, in data engineering world, this is not a new concept or software engineering, but in BI world, it somehow always seemed, or certainly in my career, taken a bit of a backstage somewhat, or been overlooked, or just whizzed past. This little picture, obviously I'm old enough to know this, but I've been in situations of business users or ex-bosses. I'm not, hopefully none of them are here today. But we don't like in BI world or analytics world, we don't like all of the SDLC stuff, software development lifecycle, DevOps, too complex, expensive, unnecessary. I want this quicker at my desk. But we like to get those things quicker because we want to make business decisions faster, So, but in order to do that, you need the data to be reliable. You need the data to be trustworthy. So what you're saying is that you don't like the complexity, you don't like the processes when it comes to BI analytics, but you love the outcome. Because everything we said about reliability, trustworthiness, security around data, that's all an outcome of a successful software development lifecycle. So what were we missing in analytics? So what we at Datatonic think is that some recent, when I say recent, I mean, it's, gosh, now 2 years in our data and cloud world is nothing, right? Like every 2 years, the entire world changes, but I mean recently, right? Some breakthroughs and DBT, tools such as DBT have brought really, really cool features that allows those kind of cool things that we're talking about, autonomy, security, reliability, all those things. And this session, Datatonic will hopefully walk you through some of those things. With that in mind, I'll pass it over to Alex.
Thank you very much, Ash.
Talk about modern data stack and DevOps in general.
Brilliant. Thank you very much. So I'm going to do a very brief rundown as to actually what DevOps is. So it's kind of nicely summarized as this quote from Darwin. It is not the strongest of the species that survive, nor most intelligent, but the one most responsive to change. So development is the process of change. Changes to algorithms and architecture, data models, deployment processes, and languages. So how can we make the software development life cycle amenable to change? but also while allowing a developer to focus on fixing the problems that they want to solve. These are the kind of problems that DevOps will attempt to fix. So I'm sure that some of you have seen some of these. I call these the DevOps greatest hits. One of the classics that actually isn't on there is It Worked on My Local. But you'll hear all of them over time. However, one thing that's worth mentioning is that the data main has very unique challenges, which we'll look at some solutions for later on. So while you may not necessarily think of DevOps and analytics being an obvious pairing, we definitely see there as being a really nice synergy between the two. We definitely think that the two practices can complement each other. This could be from automating deployment of a new schema to running automated testing before your code ever touches production, and many more besides. So when we're talking about the world of the modern data stack, this is kind of how we, at least Datatonic, kind of see the world. We're big users of Google Cloud, as you may be able to guess by the logo in the top right. Here's an example modern data stack that we would implement typically on top of GCP. As you can see, dbt slots in quite nicely to this, especially in the process and transformation layer. And obviously all of this from a DevOps point of view can be built with IAC tools such as Terraform. So I think it really bears in mind to kind of read through the title of this one. So delivering on governance requires a production mindset. So when we say production mindset, what do we mean? We basically mean how can we deliver to prod by building confidence at every stage of the delivery. So this could be from testing to SRE to monitoring. All these elements can be helped in some way or another by DevOps. We can extend the software development lifecycle workflow, which can be embodied and codified by CI pipelines to allow us to take code all the way to production with maximum confidence. So here, I think I'll hand back to Ash.
Sure. And obviously, ending this is that all of that ends in like a seamlessly integrated pipeline and all of the kind of cool stuff that we like to see in a modern data stack. So DBT as a game changer, that's a big statement, obviously. There are other, many modern cloud solutions that have come into the market, but DBT has been a real big one. That's why we're all here today, is that it's really touched us all in one way or the other when we're working in the cloud world. This is one of our favorite diagrams. It ended up being a deconstructed form of DBT, but as you can see, in those different parts where we're talking about transformation or governance or whatever, deployment, CI/CD, downstream impact, it's all baked into the framework. What that means is that suddenly you have a transformation tool which is focused towards analysts or SQL developers or analytics engineers. That's actually come from DBT Labs, right? That whole thing. But what that allows you to do is basically this. This is one of my favorite kind of gifts, which is Steve Ballmer, if you know from the Microsoft world. Analysts working like developers. Suddenly you have all this capability. And I remember talking to one of the colleagues who I spoke to earlier about, being on the business end side of things, but not necessarily an engineer, but suddenly you have the capability to work like developers and reap all the benefits because the framework solution like DBT does all that for you. With that in mind, we're going to move on to a couple of demos because we're throwing a lot of words at you. Let's see if we can turn that into something concrete. Again, a little bit wordy, but we've prepared 3 demos for you. We're going to try and be quick with each of them. Number one is we're going to show you pre-commits. If you've coded with DBT, you might be familiar with pre-commit checks. But the challenge is that so we've set challenge for each of these demos. One of them is they say, I want to inspect issues before I submit for review. What is the value? You can find trouble before you push it in. In turn, it will lead to efficiencies in how you're doing your development, pushing your data product. Number 2 is the challenge, can you automate some of the integration testing and catch issues before it goes into production? The value is obviously there to see, would you rather get a call 2 in the morning to say your data warehouse pipelines are broken, or would you rather have some degree of automation and some catch? And Alex will show you some of the cool stuff around DBT and how DBT does CI. Number 3 is backfills. I mean, if my colleagues here work with DBT day to day, backfilling is one of the most painful aspects of any data warehouse or data stack building. the challenge here is that can we introduce automation and backfill and only do targeted backfills? So A, I don't break the bank. I might have terabytes and terabytes worth of data. B is that can I keep the process of release where I do need, there's a schema change, I do need to backfill, keep the process efficient. So yeah, there you go, 3 challenges, and Alex hopefully will walk us through some of these.
Fantastic. Thank you very much, Ash. No pressure. So first, let's go through a very quick demo on the wonderful world of pre-commits. So let me show you very quickly how you can add a very basic pre-commit that will check file endings and validate your YAML right out of the box with effectively no configuration. As you can see from the example, first we install with pip. We then generate a sample config, and then we can invoke it manually to kind of check that we like what the output is. And then if we like what we see, we can then do pre-commit install. Within these 4 commands, we can very, very quickly add value to our pre-commit checks. So let's kind of quickly jump through to see what this would look like after we run. Hopefully all passed. Oh no, it's all looking good. So we can see that our sample config has already stopped us from committing mistakes just by doing this simple YAML check. So it will check for the validity of your YAML files that comprise a lot of your DBT configuration. These are all base checks straight out of the box, and a great starting point for kind of shifting left that code quality right from where your code starts, from your local. So whilst these are good starting points, how can we get some checks that are more specific to the world of DBT and for DBT code and config? So this is where we look at this example repo, the DBT checkpoint repo, open source and freely available. There are a range of checks that are targeted around sanity and quality checking of your DBT code. This is just a sample of some of the checks and hooks that are available. As you can see, we have 3 main types of hook. Checks for DBT components and primitives, such as models, scripts, sources, and macros. Then we have modifiers that will not just check your code, but will actually then make tweaks where necessary. Lastly, we have honest-to-goodness DBT commands that we can ensure have been run before that commit ever lands in your remote repository. I'm sure that you can kind of see the power of this approach. It is also possible, in fact, I highly recommend, to run these checks also as part of your CI process, perhaps on the creation of a merge request to, again, kind of give you that extra confidence in your code as early as possible through the development process. So there you go, nice and quick, that one. Let's jump onto our second, slightly more meaty demo. So integration testing and the use of SlimCI for the CI/CD process. So, excuse me. So next, we want to look at kind of testing our code. Our pre-commit checks are giving us green ticks. In the world of DevOps, we like green ticks. Ad hoc checks on the dev environment are looking good. However, the dev environment is shared. This is useful for kind of looking at what all the dev teams are doing on the environment. It's great for getting like a holistic product-wide view on delivery, but it can work against us. Running tests usually requires test data. In fact, some of these tests may end up making transformations to this data, which mutates our test set. Very quickly, developers and their work, we can kind of end up with crosstalk, and we can end up with tests overriding or hitting each other, and therefore giving us erroneous results. This is kind of a hard problem in the data domain. So what we need is the ability to create an ephemeral, short-lived copy of this data that our models can work on. We can run our tests in a clean, repeatable way. We also want our testing scheme to be uniquely named, and we want it to expire after a certain amount of time. We don't necessarily also want to duplicate our test data unnecessarily. Why copy data that our data models and procedures don't touch? This is why we use SlimCI as an approach. So here we have a video running through the demo. So in this demo, we'll take a look at how CI can orchestrate integration tests running in DBT Cloud. We can use the result of this test to decide whether or not to execute a full DBT run. So let's just go through this now. So first, we have a macro here, which the generate name schema name, where we dynamically generate a name for our tables and schemas. If the target is the SlimCI target, which we can set to an environment variable on a CI runner, excuse me. We can also create. We can also make them ephemeral, so we can set a configurable expiration time attached to our testing tables to disappear after we've executed n number of tests. So next thing we want to do to fill in the slim part of the slim CI portion, we're using the defer to run on previous run state and the select modified flag to ensure that we're only executing tests against pieces of code that have changed. And then once those have passed, we then go and execute our DBT testing step. So next thing we're then looking at is our incremental job. This is just DBT run, nice and simple. So the idea is that we have a very clear set of a very clear workflow here, where we run our tests, check those look good, and then we execute our DBT run if those tests look good. So this is we're using GitHub Actions here. This is an example workflow where we're just setting again a couple of environment variables, and we're making two calls. That is the steps at the bottom, where we're calling our integration testing job, and then we're calling our DBT Cloud incremental. The code, by the way, the Python script that calls DBT Cloud is freely available from the good folks at DBT as well. So again, very, very easy to get up and going with this. So here we triggered the workflow using a git commit. Excuse me. Also note that the pre-commit job is also executing as well. And we can now go and look at our testing job in fast motion, going and running through that. Unfortunately, it's not that fast in real life, but it's we can dream. So we can see that our testing job is now executing. We've called it successfully from our GitHub action. And we can then hopefully see in but a few seconds that it will then trigger the incremental, the actual run job as soon as that one is complete. So effectively what we're using here is we're using GitHub Actions as an orchestrator, so we can keep our logic inside of DBT Cloud, and we can then orchestrate calls to different jobs from GitHub, where we can use the wide plethora of tooling that it provides to build quite complex workflows if we wanted to. And here we can see, despite that one warning, that we have a successful run of DBT. So hopefully this has shown that we can build a dependency on a passing test to then go and apply this on our actual environment. So this kind of very roughly covers what a possible testing scenario looks like. Let's take something quite similar. Let's look at the world of backfill, but through a similar lens. So in this demo, again, we use CI to orchestrate DBT actions in DBT Cloud. But in this time, we're kind of, again, focusing on backfill. A full backfill, as Ash mentioned before, can take a significant amount of compute and time to process. And this also has a financial cost attached to it as well. So doing a slim backfill allows us to target only tables that have changed, representing considerable cost and time saving. Let's also kind of take a look at an automation where we run slim backfill as a dependency of our cloud run. So let's go and have a look at what this looks like to execute. So again, very, very similar. On this case, we've got a new Git tag coming in, triggering off our Git workflow. Again, this would be kind of great for like a pre-release step to your production environment. So we can now watch GitHub Actions do its thing. So again, in this scenario, very, very similar setup to the previous one, where we have a backfill job that is the gateway, if you like, to then providing our full DBT run. So here we can see our slim backfill run, our slim backfill job executing DBT Cloud. Again, very similarly, this is a selective fill, so again, using the state modified and deferring to previous state. So again, we only run that backfill against schemas and tables that have changed. Again, this represents a huge possible saving of time, avoiding the dreaded full backfill that we might be running in a more naive implementation. So, excuse me. Again, now the backfill has applied successfully, we can now execute the rest of the workflow. Again, because we're using GitHub as an orchestrator, we can have somewhat more advanced logic if we wanted to embedded in our pipeline. In this case, again, very simple. If the backfill runs, we run our DBT run straight after, and the workflow is completed successfully. So this is kind of an example of what this might look like to run live. So with that, I think that covers more or less the demos. I don't know, Ash, if you had anything extra to chuck in at that point?
No, I was just going to say, hopefully it was obvious from the demo that to set all this up outside of GitHub, it was literally setting up simple jobs in dbt using operators. And if you've used like states and so on and so forth, we just set up those steps, and Alex, through this harness, triggered those jobs, and it ran really quick. So it was just, again, going back to that analyst working like a developer, working together to set this up. Hopefully that came across on some of those demos. Thanks, Alex. And I mentioned earlier that we have an interesting topic here. I'll pass it over to Stan. How does Gen AI fit together in all this, Stan? How do we shoehorn this? Let's talk about it.
Cool. So, would it be a tech talk in 2023 if we didn't talk about generative AI? There's obviously been a lot of hype around the topic this year, and for good reason. So AI and LLMs have changed the way that we will work within the world. And some of those we're already seeing. So 3 of which are on the screen at the moment. So in the world of a dev or any software engineer, it will speed up that time for us to write code using tools such as Duet AI or Copilot from Microsoft. Customer experience is another example. We're all customers, and we love to be personalized. We love to be tailored to. And that will be a key use case for generative AI going forward. And thirdly, LLMs will be a game changer in the space of analytics. It will lower the barrier to entry for information across companies, giving swift access to insights instantly. So take this as an example. In the very near future, businesses will be able to get almost instant insights into their data using plain English language. Simply ask a question or a LLM prompt, such as, give me sales for customer X for product Y on a daily basis. And the model will give you the answers straight away, both in tabular and graph form. So this brings me on to the world of DBT, the discovery API. Who has used it or heard of it? A few hands. So every time DBT Cloud runs, it generates and stores information about the project. The information includes details about your models, your data sources, and information about execution as well. With the API, you can query this metadata to gain better understanding of your DAG and your models and the data that it uses and produces. By leveraging this metadata, you can create systems for data monitoring, lineage, and automated reporting as well. Now, this is awesome, this is great, but it requires a level of technical expertise to get going with. And this is how we see generative AI removing the barrier for observing your data within your DBT projects and your data pipelines. So, how might this look in practice? So let's first look at the LLM. Base model LLMs, such as GPT or Palm 2, are great general knowledge workers, but lack specific contextual knowledge about your particular use case. And now this is where the concept of fine-tuning comes in. This is where you retrain a segment of your large language model with specific information about the problem that you're trying to solve. So in this concept here, we would fine-tune a large language model using information coming from the Discovery API. So that would look like question answers about a particular topic. And our topic here would be questions that I would ask the API and the responses that it would give us back. So after we've generated this large data set, we've fine-tuned the model, which we could do on Google Cloud using Vertex AI pipelines. We would have a large language model that's fine-tuned for our use case. So how would this work? We would use a custom application. We would use something like LangChain in order to act as that interface between us and the larger language model. So step one, a person would go into the front end and ask a question such as, what is the latest status of my model? Step two, the application gives that to the large language model, and the LLM creates the query needed for us to feed into the discovery API. Step three, the application takes that query, which we've just generated, and submits that. We then get the returned answer, which could then be formatted within the application and fed to us in plain natural language, so that anyone without the technical expertise actually to use the discovery API tool itself can easily ask and find information about your project, your models, and the status of your data pipelines with ease. So with that, we have a couple minutes. Ash, do you want to close us out?
Yeah, yes. No, thank you, Stan. And hopefully we can kind of, a closing thought around the Gen AI piece is that we go back to that boss who was telling us this is all too complex to like, oh, this is fab. I can just ask simple questions and I know whether my customer dashboard is going to fail or can I do my revenue reporting tomorrow. So I think the benefits are there. Definitely watch the space because we will try and, when we come back to you next time in whatever forum, should have a demo. We had a little bit of space for Q&A, but I think what we'll do instead is that maybe try and reach out to some of you guys one-to-one when we're upstairs. We're one of the last ones today, so I don't want to stand in between you, us, and the bar. So hopefully we can take some questions from you directly. Please do reach out to us. We also have additional colleagues at Datatonic. When you see one of those faces, please just pull them out, and we will be happy to address any questions or just stay in touch. And thank you very much.